questionnaire, applying Rasch theory to assess reliability and validity of items and instruments. So the main aim of this presentation is just to introduce you to instrument validation with the application of Rasch models. So this is just a small taster. Obviously, we could have weeks of this or more. Okay, about the presenter and the presentation. I'm a research psychologist. I have a PhD in psychology. Oh, this is moving without me moving it. Let me go back. And my main focus is on psychometrics, and I'm specifically working in education at the moment. So you, the audience, you might be from a more psychological background, and that's why I've tried to use questionnaire data and also a construct that would be of interest to you. But everything I'm discussing today applies equally to cognitive tests, and that includes school assessments, large-scale assessments, any type of measurement in the social sciences, really. So we just have to cover some jargon, because I love throwing these terms around and assuming everybody knows it. But I've learned the hard way from my students that you don't know it, or many people don't. So when I talk about an item, I'm talking about a question or a statement in a questionnaire, a test, or a checklist. When I say persons, I mean whoever the respondent or the test taker is, so whoever answered it. If I'm talking about an instrument, and I do this to my students a lot, I talk about an instrument during a presentation, and then they come to me afterwards and they say, what is this instrument? So that's anything you're using, a questionnaire, a test, a checklist, anything you're using to measure. Measures we'll unpack a bit more, but those are interval scores of the construct. That's what true measures are. And the other term that we love using is endorsement. So this especially applies to questionnaires. It's just the degree that somebody rates your statement or agrees with something, that means they endorse it. So just remember, those item is a question, instrument is the test or the questionnaire, and endorsement just the degree people are agreeing with your statement. They're endorsing it. So reliability and validity of questionnaires. So this is what you were probably taught about reliability and validity. You were probably taught to calculate Cronbach's alpha for reliability, to do factor analysis to confirm constructs, to calculate averages or total scores based on Likert type responses, in other words, ordered categorical data. You might have been taught to apply parametric statistics to report your results. And if that's what you taught, then this to a degree is classical test theory or true score theory or traditional test theory. So I think if you open any book on psychometrics and introductory text, then these are the sort of things they teach you. But classical test theories has some limitations, that's why it's not generally used as much anymore. For starters, it assumes a normal distribution. So you can think for a moment, does agreeing with something give you a normal distribution? Missing data are problematic. Think especially for things like factor analysis, unless you're using imputation methods, but that's quite sophisticated and I think often not taught. And the functioning of items and persons are not modeled with classical test theory. Standard errors are imprecise. So at the extreme end of a scale, both extreme people and items distort that scale. You can think of any normal example in real life. I think I've said it before when I recorded this one, and that's that when you're trying to lose weight, if you are very overweight, it's easy to lose the first few kilograms. But if you are at the bottom end of the scale, maybe you weigh 60 kilograms, now it's going to be really hard for you to lose 5 kilograms. So we understand, I think intuitively, that scales distort at the extreme end, but classical test theory does not take that into account. Category functioning, so if you've designed a Likert scale, then you just assume it's working, and this is rarely investigated in classical test theory. But if it's not working, that causes bias in your data. And then often ordinal data are handled as though it were interval. So this is just a quote by Fried and Flake. Stop using Cronbach's alpha as a sole source of validity evidence. Alpha's considerable limitations have been acknowledged and clearly described many times. Alpha cannot stand alone in describing a scale's validity. So this, I hope everybody knows this. These are the levels of measurement. I was hoping that you would have been taught this at some point, but I just want to make sure that we are all on the same page, because if you don't know this, then you'll really be lost in any type of analysis. At the bottom end of the scale of the levels of measurement as described by Stevens in 1945, we've got nominal data, so things that can only be named, like male and female. There's no inherent order to it. Then we have ordinal data where we do have order. So there we have Likert scale type of data. We have agree, strongly agree, there's order to it. But there's no true intervals, because I don't know if somebody who strongly agrees twice as much as somebody who agrees. So no real distances. Think of a ruler. You want every centimeter to be the exact same size, and that you do not get with ordinal data. It's still just categorical. This is not true numerical data. And then we go a bit up where we really want to be interval data. Here, distance is meaningful. Every centimeter is equal in length. Every kilogram is equal. So we can directly compare and also use parametric statistics. So raw scores, the type we usually derive from Likert scales, are ordinal in nature. But Rasch can elevate those to true interval data through the transformation it does. Measurement in the social sciences. What we're trying to measure is a construct of interest. You can also call it a latent trait. And constructs are ideas we cannot directly observe. So we have a pretty challenging time measuring them. And constructs could be cognitive or intellectual. Maybe you're interested in intelligence or creativity. They could be psychosocial. Maybe you want to measure resilience or personality or happiness. They could be more behavioral. You could be interested in how people manage their time or their sleeping habits. And of course, constructs are multidimensional by nature, so they could be a mixture of these things. The example I'm using today is attention deficit disorder, hyperactivity, ADHD. So that's just the construct that I'm using as an example. And it's defined as inattention and or hyperactivity, impulsivity that is persistent and interferes with development. So if somebody has more of this construct of ADHD, it means some of the following. They fail to pay attention, they do not complete tasks, they may avoid engaging tasks, the child might be disorganized and forgetful, they have trouble in delaying gratification. They could be overly active and noisy and interrupt and intrude on others. So here we're starting to unpack the construct, and we want to measure more of this. And we also want to measure it coherently and cover the whole construct. So this is a good opportunity for you. If you have a piece of paper handy, then ask yourself, which constructs am I interested in? And what does it mean to have more of the construct of interest? And what does it mean to have less of that construct? And if you're designing a questionnaire or working with one, does more endorsement, so if people agree more with a statement in your questionnaire, does that mean they have more of the latent trait? So it's very important to understand your construct very well, especially if you're developing a new instrument, or if you don't understand your construct, to work with specialists in the field who do, to work with the experts. So let's take a look at Rasch models. What is Rasch analysis? So Rasch models apply the principle of measurements as they have been established in the natural sciences to social science data. So just like a ruler, you want your questionnaire or test, whatever instrument you're using, to be able to do the following. You want to measure in the same way for different groups. So if you were applying a ruler, you wouldn't want it to measure different people in different ways. You want it to be consistent. So you want measurement invariance. You don't want bias in your instrument, for example. Maybe you translated it the questionnaire, and now people in a different language group don't understand the question because you had translation bias. You want to measure the same underlying trait from least to most. So you want order and unidimensionality. You want to measure at equal intervals. So that's a true interval scale. And you want to have ordered categories that don't distort your measures or category thresholds. So let me just say, as a disclaimer here, I'm like you, I'm from a psychology background. So I do not like formulas very much myself, but we can't avoid them completely. But here they are in words. I always like them so much more when they're in words and there aren't ugly Greek symbols all over the place. So the probability of an event occurring, in our case, the event occurring is somebody correctly answering our test item, or if we have a questionnaire, what's the probability that they will agree with a statement in our questionnaire? It's a function of the log of personability or agreement minus the log of item difficulty. So if high school maths was a long time ago and you don't remember the natural logarithm, don't worry about it. It's just a transformation that is applied and it converts your scale to a true interval scale. So it's the log of that, the log of how much people are likely to agree with a statement. So how much a person agrees minus how difficult is it for people in general to agree with that statement. That is the Rasch model, very, very basically. So all of that you will find everywhere, but with the ugly Greek symbols that I have warned you about. So those are probabilistic models in which a person's ability, or in our case endorsement, how much they agree, is placed on the same scale as item difficulty, or in case of a questionnaire, how hard is it to agree with that question. The Logit scale usually goes from -5 to +5, and items are set to a mean of 0 with a standard deviation of 1. So if you see that scale and it frightens you, or it just hurts your brain a little bit because it's hard to think of -5 to +5, remember that it can always be rescaled from 0 to 100 if that's easier for you to understand, or any other range for that matter. So designing, evaluating, and refining questionnaires. Designing items. So hopefully you're designing according to the conceptualization of the construct. So theory-driven is how we want to design our items. The ADHD questionnaire for the teachers that we designed is based on DSM criteria. And we had the ideal, we had a panel of specialists designing the item. That's what you ideally would like to have. But I do also understand that as a student, for example, you might not have the money or the resources to get a panel, but try to get at least 1 or 2 specialists then to comment on your items, so you have some input from people in the field. So you want to design those items to be meaningful and to cover a range of the construct. So just think of our ADHD construct. What if we hadn't included any questions on impulsivity? Then we'd be underrepresenting that construct. But we also don't want redundancy, repeating the same aspect of the construct. We want to avoid both of those extremes. So when you design a scale, and maybe you'll do a Likert type scale, you want it to have order and you want it to be meaningful to the people who are answering it. And therefore you design it to discriminate, and it's very important that it discriminates on the underlying construct. So for our ADHD example, we want to be able to separate children who have more of that construct from those who have less of the construct. Maybe we want to do an intervention and we want to be able to identify the children who have the most of this problem, who are the highest on the scale. So we want discrimination by our instrument. So a Rasch recipe, here I'll start with a disclaimer that it depends on your instrument and aim. So you would adapt your analysis obviously for your data. So there's not one recipe for everybody. But I'll share with you an example here of what we did. Remember, this instrument I'm talking about was developed in the UK. So we wanted to know, will it work in the South African context? So we looked at the overall instrument and item functioning, so reliability, excuse me, fit statistics and model fit, unidimensionality and local independence. So unidimensionality, I've been saying we're measuring one construct. We want to measure it so strongly that there's nothing that competes with it. Local independence, we want items to be independent from one another. How you answer one question shouldn't influence how you answer the next one. We wanted to look at category and threshold functioning of our scale, if it made sense. We're going to do examples of all of these to make it more accessible to you. Differential item functioning, remember earlier when I said that if you have a ruler, it must measure the same way for different people. So we want to make sure none of our items are biased for any of the groups who are answering them. And construct validity. What we know about the construct, does the way the instrument then respond to that, does that make sense? Is it ordered in a way that fits with our construct? So data sets, what you would need, preferably at the very least the ability to manipulate data sets in Excel, so knowing what a data set is and how to manipulate it, but much better the ability to use some statistical software packages, for example, SPSS, because you're going to need to clean, recode, and process your data before you can put it into the software. If you don't have that, find out from your university what software packages they have and also what free in-house training is available. You'd be surprised at how much there is actually in many institutions or universities. There are, of course, many online courses like statistics.com as well as YouTube. The last option, if you really don't work well with data sets, then work with somebody who do understand what they're doing and can work with data. The example I'm using here is teachers who rated grade 1 learners on an ADHD scale. So 1,571 teachers answered the questionnaire about the children in their class. So depending on the software, then you prepare your data in Excel or the other software packages before you import it into the Rasch or IRT software. You check that your data are clean, that you've dealt with out-of-range values, indicated missing data, use a value to indicate that, and only include relevant variables like the ID. Person factors is, for example, gender, and then the actual questionnaire items. And remember to recode questions which are not in the same direction as your construct. So again, most people know this, but I've also learned again the hard way that that's not always the case. So let's say we have a scale that measures the construct of depression, just an example. So we want to measure this construct as a whole, and we want to measure in one direction. So our first question says, I often feel I'm worthless. So somebody perhaps strongly agrees with that construct. With that question, so they have more of the underlying construct depression. Number 2 says, at times I think of killing myself. So again, here on a more endorsement, more agreement with the statement means more of the underlying construct, so more of depression. My life is meaningless. Again, the person, we hope if they've been consistent, they say they strongly agree. But now look at this last item. Most of the time, I enjoy my life. That's going in the opposite of the depression construct. Sorry, get back there. So hopefully, if people are answering this consistently, somebody who's high in depression, they would say they strongly disagree with that statement. So remember in your data, easy to do this in SPSS, to reverse score a question like that, so that 1 becomes 4, 2 becomes 3, 3 becomes 2, and 4 becomes 1. So question 4 must be reverse coded as it's measuring the opposite of depression. So again, I always assume people know this, and I'm just repeating it again, because if you fail to do this, you're going to have problems in your analysis. Make sure you read every single statement in the questionnaire and that you understand what direction it's going, what's the underlying construct you're measuring, and that you code your data in such a way that they're all going in the same direction. this is what your data set might look like. So I had, for my person factors, I had a unique ID number, and I also wanted to look at gender. And then, of course, I have my questionnaire items. So this would be already clean data set, nothing funny in here, missing values are indicated, and it's all ready to import. So once it was put into the Rasch software, the first thing I looked at is model and item fit. So Rasch principles the model fit. So the Rasch model basically says persons who score higher on the construct should be more likely to agree with the difficult items. So a child who overall is higher on the ADHD questionnaire, the teacher should also have agreed more with the difficult items. I think that's what I said here in this sentence. So first we check the overall and item functioning. You check the reliability of respondents as well as items. So in our example, we've got a person separation Cronbach, which is a person separation index, which is similar to Cronbach's alpha, 0.968. We've got an item separation index of 0.949. So we've got high internal reliability using Cronbach's criteria and a range of persons and abilities. We have a chi-square, which unfortunately is statistically significant. So if you're doing any sort of modeling, structural equation modeling, for example, you know we were hoping for a non-significant result, because what it's done now, it's taken the Rasch model, then it took our data set and it said, are these two things significantly different from one another? And yes, they are. So in other words, there are questions that are problematic that we need to work on. Some part of the instrument is not functioning well. So that gives us a clue already that there's some things that need improvement. And as you improve the instrument, as you improve questions, you'll also see Cronbach's alpha going down and becoming less significant. So the summary statistics, I'm not going to discuss all of them in detail because of our limited time, but I'll just highlight what immediately stood out for me here, and that is an extremely large standard deviation. So remember before I said the mean of items is set to 0, and we have a standard deviation of 1. So look at that massive standard deviation, 6.59. That's for the items. On the other side, we have the persons. We also have a massively large standard deviation here of 2.593. And as we dig into the questions and how they're functioning, especially for the different groups, then we start understanding why our standard deviation is so large and why we're having a problem. This frightening looking table, not that frightening, is the item fit. So it's whether each and every one of the items fit the Rasch model. And if you look at the far right-hand side, you can see I highlighted in red every item which had significant misfit, which is most items. So in the software I use, it automatically applies the Bonferroni correction. So the P there, 0.0000556. So most of our items actually misfit the model. And we're going to have to dig around a little bit to understand why that might be. A large standard deviation already gives me an idea. Next, we looked at unidimensionality and independence. So unidimensionality, we want to measure one underlying construct. And Rasch, most programs provide you with principal component analysis. Sorry, let me just drink a bit of tea. It provides you with PCA, principal component analysis. And because we want to measure one underlying construct, we want our first principal component to be very strong, and it is. It's 33.58%. And we have no eigenvalues greater than 2. So I'm assuming a little bit of factor analysis knowledge on your part here, but this is the criteria. We don't want eigenvalues greater than 2, and we want the first component to explain most of the variance. Dependence, so I didn't put the correlation matrix in these slides, but there were items with correlations above 0.4. In other words, items that might be too strongly correlated and could be redundant, as well as a few negatively correlated items. So be warned, if you don't go and reverse code items, that's when you find the negative correlations. And it could also be other problems with the item. Next, we looked at categories and thresholds. This is an example of an item that's working well. The item asks teachers, does the child make careless mistakes in school work or other activities? And we have these beautifully ordered mountains, and teachers were asked to rate that child from never to always. So the child never makes careless mistakes. So they could go 0, 1, 2, 3, 4, or 5. They always make mistakes. And at the bottom, you can see it goes from -4 to +3. So from less of the ADHD construct to more of the ADHD construct. And as the child has more of the construct, so very neatly are they also more and more likely to have scored higher. So this is an example of a very well functioning item. Nice, neat mountains. And because in this questionnaire, most of the items had categories that were functioning well, I'm just showing you an example from another instrument where it didn't function well. This is from a maths test. So category 1 doesn't work. So we had to combine it with one of the other categories. And you can see here in this item where the person answered the maths test, if they answered an item in a maths test, they could either have a 0, so they got the question wrong. They could have 1 if they had one of the steps right, or they could have had a 2. But the 1 falls flat, so that it's meaningless basically. Most people got a 0 or a 2, and 1 doesn't have any meaning, which is why we had to collapse some of those categories. This is an example of disordered categories from a different ADHD questionnaire, not the one I'm using today. But the question asked, as a teacher, I can provide tactile tools, for example, fidget tools, for children with ADHD. So here the teacher could have strongly disagreed with that statement. She could have disagreed. She could have said she's neutral, she could have agreed, or she could have strongly agreed. And immediately what you notice here about the categories is that the ones in the middle are disordered, and neutral is especially malfunctioning. So whether or not a teacher can provide tactile tools, they can't really say they're neutral about that. So you need to ask yourself, do your respondents think about questions in the same way you do? That's why it's so important if you're designing a new questionnaire to do qualitative investigation, especially focus groups could be very useful. And maybe being neutral about having tactile tools is meaningless. This actually looks like, to me, it looks like it should be a dichotomous item. So either they have these tactile tools or they don't have it. But there isn't this whole range in the middle where they can provide it to some degree or another. So I think they probably only have it in their classrooms or not. But we'd have to confirm that by doing the qualitative side and finding out how teachers perceive this. So the internal construct validity, remembering that we're saying that it's very important that our construct functions the way we think it should. This is a person-to-item map. On the left-hand side, we have the people represented by hashes. On the right-hand side, we've got items. And it's going from least to most. So at the top, we have the more difficult items, more of the ADHD construct. At the bottom, we have less. So statements at the top are more difficult to agree with. Statements at the bottom are easier to agree with. So you would need to look at this carefully and say, so it's easier for people to agree with careless, being inattentive. Does this mean having less ADHD? And it's harder for teachers to agree with runs excessively, blurts out answers, overly active. So this might mean having more of the construct. And you'd have to look at this map and say, does it make sense? Does the order of these items make sense in terms of what I know about the construct? Invariant measurement. a fancy way of saying we want our items to function in the same way for different groups. We don't want any bias in our items. So the first one we found is gender. For quite a few of the items, the way that teachers rate boys and rate girls is significantly different. So this item asked, does the child talk excessively? And teachers are far more likely to endorse this item, to agree with this item if they're rating a girl versus rating a boy. But to such a degree that the item now functions significantly differently for girl children than for boy children. So that's one of the things that's creating noise in our data, one of the things that's giving us that massive standard deviation and is being problematic. The next one was the languages. And for many of the items, immediately saw that for the isiXhosa group, the way that isiXhosa teachers answered forgive me if I get the click wrong, I'm trying very hard, but the way they answered those questions, they answered it significantly differently than the English and the Afrikaans teachers. So this question says child is distracted by extraneous stimuli. Across the board, isiXhosa teachers are far less likely to endorse this item. So the items were also functioning differently for the language groups. So results of our ADHD questionnaire, we had high person and item overall reliability. We have well-functioning categories and thresholds, so that was cool, very happy about that. And we have evidence of unidimensionality. The ADHD construct is one strong underlying thing. There's nothing interfering with it. So those are the positives. But we have some places, some areas that need work. So this questionnaire that is developed in the UK doesn't work completely as well as we would have liked it. Some of the items might be redundant, which are highly correlated. But here you need to talk to the specialists. Never just remove an item. That's a no-no. You first think carefully about that item, because what if it's an important aspect of the construct and you now go throw it out and then you're not measuring that part of the construct. So be careful. That's why you need to consult people who really know and understand the construct. So our items function differently for boy and girl children when they're rated by teachers, and also many of the items significantly differently for the isiXhosa group. So we've got differential item functioning. In other words, our instrument is not functioning in the same way for these groups. That's I think what's creating our lowest standard deviation. And indeed, as soon as I split the groups, then that huge standard deviation disappears, the model fit improves, etc. But then you need to ask yourself, if the items are functioning differently for the groups, is there bias in the items? Is the way the item is written problematic? Or are these actually different populations? Because it should function the same way for the population, but perhaps for boys and girls, the construct of ADHD functions so differently for these two groups, we need to define them as two different populations. So this is why you need to understand your construct so you can make these decisions. So I would then recommend for this instrument analyzing the isiXhosa group separately, as well as splitting males and females in the analysis, the boys and the girls who were rated, because the items function differently for them. And then my last recommendation, focus groups with the isiXhosa teachers to understand how they see the ADHD construct. Maybe it's different in their context, and that's why they're answering our questions in a different way. We won't know that unless we do a bit of a qualitative investigation there. And we can definitely not assume that our instrument works the same way for them as it does for the other language groups. So in terms of software availability, unfortunately, you can't do Rasch analysis in SPSS. You do need some specialized software. Here are some of the popular programs. We have WinSteps, RUM 2030, which is the program I've used today, but I use both WinSteps and RUM. Conquest is very popular in the East for some reason. Excalibur is a lovely program. I haven't used it in years, though. R is freeware, but tough to use. M+ is quite expensive, but very useful. And you can see there's a link you can go to. There's many options. But I think we all know this, the more user-friendly software becomes, the more you pay for it, because what you're paying for is that beautiful user interface, because that's what somebody spent a lot of time setting up. WinSteps is more affordable at $149, and what's nice about it, you pay that $149, you've got it for life. And the same for RAM, but that's considerably more expensive. M Plus is a bit of a bugger because you have to renew the license every year. So if you're serious about psychometrics and doing these type of analyses, I would say find out if your institution has licenses or if you can access those licenses somewhere. Our center, we have licenses, and we also train people on using Rasch. So when they come to our workshops, we often give them our contact details, and then if they're part of our institution, we haven't really discussed outside people, but we could include them. We do allow people to come and use our software because we're trying to promote all sort of measurement in the social sciences, to make it scientific, to make it rigorous. That's one of our biggest problems in the social sciences, that the natural sciences can point to us and say we don't measure scientifically, and we're trying to change that. Applying Rasch analysis is one of the ways. You want to have the best possible instrument giving you valid and reliable inferences that you can really use, and especially if you're making high stakes choices. You don't want somebody flying a 40 million rand plane, then they're not capable of doing it. And you don't want to allow people into, say, an engineering degree at university, and they don't really have the underlying skills or ability they need to. This is why we need strong, robust, rigorous measurement in the social sciences. So as I say, sometimes we're dealing with very high stakes. So our conclusion: applying Rasch models provides evidence of internal reliability and validity for questionnaires and tests any instrument. So it's testing the test, basically. Is there seeing if the items and categories are working? And that gives you the opportunity to refine or remove items. So you need to refine items which display misfit or lack that invariance, that have differential item functioning. But you do that, of course, with specialists in the field. You want to combine categories that don't work because they will distort your measures. You want to remove redundant items, improving basically your assessment instrument overall, so that you can report reliable and valid inferences if the items and the instrument are functioning well. That's what you want. You want to have robust instruments that you can use with confidence, and that treats people who are answering them fairly as well. Because as I say, sometimes we have very high stakes, and we want to be both scientific and ethical. And I think sometimes those two are intertwined. The more scientifically rigorous our instruments are, also the more ethical our assessment becomes, because we've set up strong instruments that give us true reflections of the construct we're trying to measure. There is just a very long list of references. Obviously, I have many more than that, but those were the main ones I used to some extent to inform today's presentation. I think we've reached now the question and answer section. Mahan, are you still there?
Hi there. Thanks, Celeste. We can open up for any questions. Thank you very much for that great presentation. It was so lovely and so informative.
It's a pleasure. I'm just sorry my throat didn't want to work well.
No, it's fine. It's fine. I don't think there are any questions right now, but what we can do is we will post this online. And if any questions come up on the social media sites, I can send you an email with those if we can't respond to them. And then perhaps you can engage with it on the Facebook page.
Yes, that's perfect. I'm very happy to do that.
Awesome. I did record this session, so I can also send you a copy of the session afterwards.